Let us now discuss how can we solve this problem. Frog jump. So LeetCode problem number 403, frog jump. So this is the first time I am viewing this problem. So let us just read what is given in the question. Right? A frog is crossing a river. The river is divided into some number of units. Let us just write what I got. So I'm just writing it over here. So here a frog is crossing a river, right? So let me imagine there is a frog something like this. So the frog is crossing a river. The river is divided into some number of units, and at each unit there may or may not exist a stone. So let us consider some stones. Let us use a brown color for that. So there will be stones at some points and there will be water in some units. So we are divided this with units, right? Now, where are we? We are in this frog is in a river. It need to be crossed the river. It should cross the river, right? So may or may not exist a stone. The frog can jump on a stone, but it must not jump into the water. So the frog can jump only to the this stone or rock, right? So if not, it will go into the river and it drowns. Even those frogs know swimming, no matter, but it should land only on stones. It should not land on river. Now, given a list of stones, positions, right? So we are given with stones, nothing but positions. That's what we are given with, right? Stones positions in units in sorted ascending order, right? Okay, that means here if I start with 0 1 and so on, I go till some point. So it is started that first stone is given, second stone is given, third stone where it is, fourth stone where it is, we are given with this uh, data. Determine if the frog can cross the river by landing on the last stone. So if I consider this last stone, I need to determine whether this frog goes to this stone or not. But it is not something like easy task, right? There will be some constraint. Let us go with the whole question, right? So determine if the frog can cross the river by landing on the last one. So I picked up this as a last stone, right? Initially, the frog is on the first stone and assumes the first jump must be 1 unit. This is like, I think, the important thing, right? Frog is on the first stone and starts with starts with 1 unit of jump, right? I'm not wrong. I think I'm not wrong. The first jump must be 1 unit. So, and starts with 1 unit of jump. So, let us take that here. Let me take here, I have a stone. I'm just imagining that I have a stone here. Now, after that, there is a stone here, and there is a stone, the last stone here. I'm just taking the values. So it is 0, 1, 2, 3, 4. Whether the frog, can the frog goes to the last stone? Let us see. Let us see. That we said that we can start with 1 unit of jump. So it can only jump to this one and it eventually falls down, right? So it starts here at the first stone and it should definitely go to the next unit. That means must start with 1 unit. Okay. Now we are given with If the frog's last jump was k units, its next jump must be either k minus 1, k or k plus 1 units. The frog can only jump in the forward direction. So I said there will be some constant here. So if the frog's last jump, let me say, there is this frog and it has jumped something like k units. I'm just assuming that it jumped k units, and let me say that k is equal to 5. That means it jumped 5 units. I am just assuming that it jumped previously 5 units. Now next, it can jump k minus 1, k or k plus 1 units. That's what we are given with here. K minus 1, k or k plus 1. So it can jump k minus 1. What is k minus 1? 4. K is 5 and k minus 1 is 4. And k is 5, k plus 1 is 6. It can jump 4, 5 or 6 units away, right? The frog can jump only in the forward direction, right? If it can, uh, no, wait a second, right? So you might say that go here to this rock and go to the previous rock. No, it is not allowed. We are only allowed with forward jumping. We can only go forward. The frog can only go in the forward direction. Let us see how can we solve this. I think you have understood the problem. Don't know. Yes, concurrent viewers don't know what about it, right? So capture moment as they happen, or let it be. Okay, okay. So we have gone through this description. So I go with when I hit a hard problem, right? When I go through a hard problem, first I read this description and make something like this, some drawings like this, so that I can easily understand. So what I understood here, let me write it. That's what I do every time. So what I understood is definitely first thing, there is a frog. There is a frog. It's what we are given with. We are given with, I think only we are given with only stones. Yes, vector of int stones. So we are given with we are given with stones. These stones are nothing but positions positions where stones are present. That's what stones mean. Positions where or units where stones are present. That's what given, right? Stones are present. Okay. Now we are given with a frog and also stones, right? Now we are given with the third thing, right? A frog stands on the first stone, stands on the first stone, right? And this is the condition that we are given with, right? That's what we are given with in the description. Frog must jump one unit, right? One unit. And most importantly, frog should not drown. Frog should land only on stones. Nothing but we need to land on stones instead of the water. This frog need to cross the river, right? So it should not get wet. Now frog should land only on stones, right? There is another condition. uh, Frog can jump k minus 1 k or k plus 1 units if previous jump was k units. So I took the example as k units, as if k is equal to 5, then the frog can jump 4, 5, 6. Now I think you have clear cut about what the description says. Now let me go with the constraints first, And let me go with the examples next. That's what I'll do every time. So stones dot length is 2000, which is much lesser compared to like 10 power 5 or 10 power 3. LeetCode also gives like that. So 2000 is much lesser compared to those values. Now stones of I, so it starts with 0 and can go till 2 power 31 minus 1. It means 2 power 31 minus 1 means it is int max. So a beautiful thing here is 2 power 31 minus 1 is nothing but int max value. Int max value. So it can go from 0 to 2 power 31 minus 1, right? And stones of 0 is always 0. So this is also a good constant which need to be known. Stones of 0 will be always 0. That means as we said that, as I said that frog must so frogs stands on the first stone. Nothing but frog stands at 0. So every array, every test case starts with 0. So there will be a rock or stone, right? So there will be a stone which is reserved for this frog. So the frog, sorry, frog will be in green color, right? So this frog will be here on the first stone. So the units is 0, right? So the units is 0. No need to worry whether the dog is sorry, frog is at 1 unit, 2 unit, no worries. It will always start at 0, right? Okay, now stones is in ascending order or increasing order. That's what we are given within the description. Let us check this stones first example. So stones are given as, excuse me, 0 1 3 5 6 8 12 17. Now first thing what I need to do is the dog, sorry, frog is at here, right? I said it goes with one step firstly, right? So it went here. Okay, we are gonna go in the forward direction, right? Now here I took a step of 1. Now I can take 1 minus 1, which would be 0, nothing but if I am taking 0 steps or 0 units away, that means you might get confused like this. So, right? Okay. So what I am doing, let me take 17 till 17. Let me take till 17. 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17, and I am placing some rocks here where I got a rock. So 17 and then 12 and then 8 and 6 and then 5 and then 3 and then 1 and then 0. Okay, now we are clear, right? So I have the frog here and it goes with one step, so it will be here. Now I can take, I took one step, right? So in the next step I can take, if I took k steps, right? I just do like it, right? Okay, so I took one step. So if I took steps, if frog take k places or k units, then k minus 1 k or k plus 1, right? So here k minus 1 is 0 and k is 1 and k plus 1 is 2. So if I take 1 plus 1, which is 2, I will this frog, sorry, this frog will eventually drown into the river. So what if I take two steps? 1 plus 2, I'll land here. The frog will land here. 3, safe. Now how many steps did I take previously? Two steps here, right? Now I can take one step, k minus 1, k and k plus 1. 1, 2 or 3. Yes, I have a provision that I can take 1, 2 or 3 steps. Let me just take one step. Then I land here, right? the frog land here and it will drop. If I take 2 steps, then I'll land at 5, which is a stone. If I land here, the frog lands here. After 3 steps, it drowns into the river. So what I'll do, I'll just take 2 steps, jump off 2. So 2, so I am at 3. I can take 1 jump or 2 jump or 3 jumps. So I'll take 2 units of jump. The frog will take 2 units of jump and land here. So how many units of jump I took? The frog took 2 units, right? Now here also I have 3 options, 1, 2 or 3. So doing the same thing, but here I have here I have 2 options. I can land here or I can land here with 1 step and with 3 steps. I don't care like whether it is taking minimum steps or maximum steps. This frog doesn't care about it. 1 step, 1 unit or 3 units. Okay, here comes the conflict, right? So let me just tell it like this. So if I took 1 step, let me go with 1 step, right? Let me go with 1 step. I'll tell you how. So I'm going with 1 step, then I'll be landing here. So k is equal to 1. I took 1 step. K minus 1 is 0. K plus 1 is 2. Now I can take 0 steps. 0 steps is nothing but I am not taking any step. I can take 1 step. So I'll be landing here, which is nothing but I'll get dropped. Now I can take 2 steps, right? I can take 2 steps and go to this 8. Okay. I'll take this and now how many steps I took? 2 steps, right? Okay, I took 2 steps. Now how many steps I can take? 1, which is nothing but k minus 1, 2, nothing but k, and k plus 1 is 3. I can take 3 steps at max. Let us see. By taking 1 step, I'll drop. By taking 2 steps, I'll drop. If I take 3 steps, I'll drop. So you might return false here, but wait a second. We took 1 step here, but what if I took go back? Let us just go back. I'm just doing undo, right? Undo. I think it's undo, right? So 1 and 3. What if I take 3 steps, right? So if I took 3 steps, then I would be landing here. Now after that, as I took 3 steps, k is 3 and k minus 1 is 2. K plus 1 is 4. Okay, I can take 2 steps. So after this 2 steps is here, which is nothing but I'll be drowning here, and also by taking 3 steps here, I'll be drowning again. Here there is a stone. So if I take 4 steps, then I'll be landing here. So I'll take 4. Okay. Now after taking this 4, our k is 4, right? Our k is 4. K minus 1 is 3. K plus 1 is 5. Now, by taking 3 steps, I'll be here. By taking 4 steps, I'll be here, which will be drowning for the 2 steps, for the 3 and 4. By taking 5 steps, I'll be here. So, I have landed at the last stone, right? So, how many options I have? So when I have options which are nothing but k minus 1, k comma k plus 1, let me initialize like this, right? Let me initialize like this only, right? So I came with steps, right? No, let it be k. So firstly k will be 1 and then it can be 0, 1 or 2. So we have 3 options. So 3 options, which are nothing but k minus 1 comma k plus 1, right? So I have something like, I have three options. I can go with k minus 1, k, or k plus 1. So first thing, firstly, uh, I will start with one step, right? The frog starts with one step. Actually, it might be something like three options. Firstly, firstly, I'll be having only one option, right? At 0, at index. So 0 here, right? So I'm taking only one step, and if there is, I don't know whether I have it or not. So let it be. Let it be 1, 2 till n, or till the maximum or nums of n minus 1, or stones of n minus 1. Why? Because here also I have this as the last stone. So that's what my endpoint is. So stones of n minus 1 will be the last point. Now, here 1. I need to know, first thing, I need to know whether this is a stone or not. If it is a stone, then what I'll do, I'll just explore other ways. K minus 1, I'll explore k, or and k plus 1, and if it goes here, then at this moment of time, what I'll do is I will return true here, and will return, and then at this point it will return. Now at any point, if I doesn't get this stone, then I'll return false. I'll tell you how. So what I'm thinking about is, first it should be 0 and the next element should be 1. That's what I'm thinking, right? First it should be 0 and the next element should be 1. Why? Because it only takes one step, firstly. So first intuition, let me write this as intuition. So stones of 0 should be 0. However, it will be 0, right? It is given in the constant. Stones of 1 should be 1, as it takes one step. Now I think, yes, we'll be starting with our recursion. I'll tell you why recursion. Why? Because I have three choices, k minus 1, k, and k plus 1. Starting with here 1. So k minus 1 will be 0, k plus 1, sorry, k will be 1, and k plus 1 will be 2. So if it is 0, k is 0, then no need to do anything, right? Right? Okay, let it be. So recursion. How do I write this recursion? Let me write some function here. I'm just naming it as function, and int. I'm starting with k. Right, k, and then let me give also this stones. Now I'll go with k minus 1, k, and k plus 1. First thing is, right, where is it landing? Right, first thing, where I am, right here it started with 1 and went to 3, right? So where it landed, and I am naming it as position. So what is the previous steps I took, and where I am, where is the position, right? Where is the units? So okay, int k, vector of int stones, int position, right? So first thing what I am thinking is, I'll call with k minus 1, k, and k plus 1. So call with function of k minus 1 and stones, right? K minus 1, right? Okay, stones, I'll call for stones, and position, if you think, let it be. So here is the stone, right? Stone at point 1, 2, 3, 4, 5, 6. So I took only one step. Now k minus 1 comma k plus 1. Now I need to add k minus 1 to the position where I am 1. So I'll do this only if k minus 1 is not equal to 0. Why? Because if k minus 1 is equal to 0, that means we are at the same position. So no need to do anything like that. So k minus 1 and position plus k minus 1. You might be wondering with why I am using this k minus 1. Position plus k minus 1. I'll tell you why. So imagine you are at 5 and the what I need to say k, that means the previous steps I took is 3, 6, 7, 8, 9. I don't know whether there are stones or not. I don't care about that firstly. Now I have k is equal to 3, right? Now I need k minus 1, k plus 1. Now where is the position? Position is 5. That's what I said. K here is 3 and position is 5. I need to know where the position is so that I can know whether the position is the last position or the last stone or not. Okay. Now I have another doubt that can I go with all 2000 or every time? No, I cannot go with all 2000 stones, but for that I need to go with other things, right? Instead of passing the stones, I need to pass another thing, whether the position is having a stone or not. Okay, whether the position is having a stone or not. Let me write it. Whether the position is having a stone or not. I need to know this. How do I know this? But before, let me come to this k minus 1, k and k plus 1. K minus 1 is 2, 3 and then, sorry, 4, right? 2, 3, 4. Now taking 2 steps, k minus 1 steps. So what will be the position after taking k minus 1 steps? It will be 7. After taking k steps, it will be 8. After taking k plus 1 steps, it will be 9. So that's why I will be adding position plus k minus 1 or k plus 1, whatever it might be. So let me initialize this as a. A is equal to, but a will be true. I'll tell you why. So wait a second. A will be, wait a second, I need to initialize it as false. Why? Because if k minus 1 is not equal to 0, right, only then only it will be having a true, or it might be a false, right? So what you might get it if I write it. So function of k, sorry, wait a second, k, so k minus 1, yes, okay, k, and then instead of I'll change these tones in few seconds, and then position plus k, right? And c will be function of k plus 1 comma stones comma position plus k plus 1, right? So return if any of this is true, a or b or c is true. That means by taking any of these steps it is returning true, so I will be returning true. But why I initialize this as false? If this has written me false, if this has written me false, and in default I have initialized it as true, and if k minus 1 is equal to 0, then true will be returned, even if it is not a true, right? So even if it is not exploring, so the default value will be false. But as I said, I need to know whether the positions having a stone or not. So for that, the idea will be using a hash map, which will be having something like, so how do I go with this hash map? Like for int num in nums. So let me initialize the hash map first. So hash map will be unordered map, right? In C++, if you are solving in Python or whatever it might be, then don't worry. I'll be giving the code after this live session. MP, right? MP of num plus plus. Now, first thing, I'll return false if there is no stone at this position. So I said that instead of stones, I'll be getting through another thing. I'll tell I said right. So instead of the stones, I'll be using unordered map of MP. Unordered unordered map of int comma int MP. Nothing but unordered map MP, right? So if MP of position, so if it is 0, right? So if it is not there, something like in the hash map, I'll tell you what happens in hash map. So this is something like a basic if you know about hash map. So in a hash map, it will be storing like this: 1 is present for 2 times and 3 is present for 1 time. Now this is in MP. MP of 1 returns true, sorry, 2. MP of 3 will be 1. But what about MP of 5? It will be default value of 0. That's what in hash map does. What will be MP of 100? Any number instead of 1 and 3, it will return 0. So if MP of position is equal to 0, then return false there itself, right? So I'm returning false there itself, right? Is there anything that I can do? So there is another thing, right? If position is equal to, I need to also send this stones. Why? Because that's the last point, right? So stones dot back, nothing but the last element, right? If position is equal to stones dot back, then return true, right? So this will be our function. Now you might be confused with what will be in the recursion function, what will be sending. That I think this might run or not. I am not sure about this. This we might memorize it or even optimize it. But before that, let me go with vector of int stones. I know that this writing is not so good, but let it be. Okay. So I have this position plus 1. Let me make it here, and I have this stones. So I have this stones here, right? Now I have MP. I just said that I'll be using MP. So let me just copy it and paste it, right? So that there will be no extra work. So I just I just need to code it here. I just need to code in LeetCode. That's what remaining here, right? MP comma position. Let me small the size for this. Okay, I am also small. I'm just making a small size. Okay, so position plus k, it will be plus k here, and it will be k plus 1, k plus 1. So position plus k and position plus k plus 1. Now in the main function, whatever it might be given, so what I'll do is return. So what is in k? Uh, okay, the position will be 1, however. Uh, but before that, k will be taking one step and going with uh, stones of 1 and unordered map. I'll tell you how I'll be initializing. This is the same thing. That's what I initialized it. Just let me copy it, right? So I have got this unordered map int comma int, and first thing, if nums of 1 is not equal to 1, then I'll return false itself. So let me make this of small size, right? So even before it, we can return if nums of 1 is not equal to 1. If stones, right? Sorry for the confusion. Stones of 1 is not equal to 1, return false. Why? Because it is taking one step. The frog is taking one step at index 0. It need to go only one step, and the next step should be stone. If it is not a stone, then it will drown. However, it can't even reach. The first step is itself one, right? Okay, so recursion of mp comma, is there anything? Yes, position comma stones, right? Position, where is it? The position is at 1, and the what is this? Stones, right? Stones will be returning this itself. Return, I need to write it as a function. Return function of this is the thing which we will be writing in LeetCode. That's what we'll be writing. Let us go with this thing first. If stones of 1 is not equal to 1, then false everything. If stones of 1 is not equal to 1, return false, right? After that, unordered map int comma int, right? Unordered map int comma int mp for int num in stones. Sorry, I think I made a mistake here. Yes, it will be stones instead of nums. So it been a practice that nums will be given every time in LeetCode. So int nums of stones, int nums of stones, mp of num plus plus. Now after that, I need to return function of I need to initialize 1 comma mp comma 1 comma stones, 1 comma mp comma 1 1 comma mp comma 1 comma stones. So let me initialize this bool function. What it will be? Int position, no, k, int k, and then unordered, wait a second, unordered map int comma int ampersand mp, and then in position, and then stones vector int stones. I think it might work, right? Okay, I'm not sure, but let's see. If mp of position is equal to 0, if mp of position is equal to 0, then return false there itself. And then if position is equal to status dot stones dot back, if position is equal to stones dot back, then return true there itself. Now uh, so a is equal to false, that means bool a is equal to false, and then I initializing b, and then also c. Now there is only a case where I have starting with 1 and went k minus 1 as 0. That's what only thing. Is there anything that we need to make this also be also initialized defaultly as false? No, I think nothing, right? There is nothing like that. Ankit bro, hi bro, hi Ankit bro. So welcome to the stream. So my name is Sidhu. I'll be following LeetCode today. LeetCode today, the frog jump game. So if you have any doubts, you can just ask me. So bool a is equal to false. Is there anything that I am missing? No. Okay. So a is equal to false, b is b and c, and if k minus 1 is not equal to 0, then only a and all. So if k minus 1 is not equal to 0, then only a will be function of k minus 1. What is the last thing I took? Is k minus 1 and mp. Wait a second, mp comma position. Position is nothing but current position plus k minus 1, right? And then stones. However, now b will be the same thing, but let me just copy this so that, so k here, right? K here, and k plus 1 here, k plus 1 here, it will be b, and here it is c. right? Okay. After that, return A or B or C. Okay, let me just do a run for this and let me tell you. Okay, it's got accepted. First time I have solved a hard problem which got accepted in this only test cases, right? Only two test cases, right? I have just submitted it. I think max it won't be get accepted. Yes, it got a time limit exceeded, so we need to memorize it. How can I memorize it, right? So first thing, when we are memorizing that, the point which I got while memorizing many problems in DB, basic problems, is what are the things that are changing in our recursive code that needs to be memorized. So let me take this recursion code and observe what are, let me write it. What are the things changing? What are the things that are changing? What are the things that are changing, right? That's what I keep in mind whenever I memorize. So however, I'll be initializing a DP, but okay, I'll be taking steps and I'll be taking the previous one every time. Okay, the things which are changing is not MP is not changing, stones is also not changing. Instead, the position and K. Okay, I think this is clear. So what I'll do, what will be the position at max? Uh, the K will be, wait a second, the K will be till 2 power minus 31 minus 1. No, it will be max. Okay, so what I'll do, I'll just initialize a 2D DB, but I am confused that whether to take the position first or K first. So to get a position, I can take so no, nothing to worry, right? So it can be K or it can be position at the first point in the array. It doesn't matter. But is there anything that need to be considered here when I am memorizing? No. So what I'll do for now, what I am thinking is creating a DP. So let it be just like it. So vector of vector int dp, right? So here I'll be resizing it, however. So the K will be max, right? Okay. Okay, dp dot assign. Here dp dot assign. I'll tell you, I'll tell you just something like dp dot assign. What is the maximum that I can get is nothing but stones dot back, right? That's the maximum stone that I have. So let it be last is equal to, every time I can't use this stones dot back, right? Back is equal to last is equal to stones dot back. db dot assign last plus 1 comma vector of int last plus 1 comma minus 1. Okay, I got assigned this DP, right? Now I'm just globally, what I say, globally initializing it. Now here what I'll do is, if DP of, I'm saying it as K and then position. If it is not equal to minus 1, then return. Now there is a problem. It might be a 0 or 1, right? Okay, okay, it might be a 0 or 1. So vector of vector bool, let us say it as bool. No, if it is a bool, I cannot initialize minus 1, right? Okay, if it is only 1, I would get true, right? So no or no matter. uh, but we are returning here, we are returning a bool function, right? So what I'll do, I'll just return int. So I need this as int answer is equal to function of something, and return answer is equal to 1. If so, I'm just writing it over here, right? Answer is equal to function of 1 mp. So let me write this db. Wait a second. Before writing, I need to do some changes here. So here, instead of return all this, what I'll write is return dp of k position is equal to a or b or c. Uh, right? If anything is true, then it will be 1. If not, it will be 0. That's what I'm thinking. So here, instead of return false, I'll be returning 0. Instead of returning true, I'll be returning 1. Let me just change it. Returning false, I'll be returning 0. I'll be returning 1. Okay. So first, let me initialize dp vector of int dp. So dp dot reassign. Okay. dp dot assign. So I said last, int last is equal to stones dot back, stones dot back, dp dot assign last, last, wait a second, last plus 1. So there might be a problem here, it might raise a problem here, right here with 2 power 31 minus 1. Okay, let it be, let us see why. Because why I'm saying it as, because if, what if the last element is 2 power 31 minus 1, which is nothing but int max. Now int max plus 1 can't be stored in integer range. First let us see whether it gives a wrong answer or not. So vector int, I'm just doing something like this, last plus 1 comma minus 1. Okay, how I have initialized this db. Now return 0, return 0 dp, let it be mb of position is equal to 0. So here, first thing, if dp of k and position is not equal to minus 1, then what I'll do, I'll just return dp of k and then position. That's it. Here also dp of k, wait a second, k position is equal to, if it is so, then 1. If not, it will be 0. Okay, is there anything? No, I think this assign might be wrong. No. Okay, I got this, but time limit exceeded in the previous code for recursion. Like I might expect this, which is having 999. Okay, okay, it got accepted, but let me do submit it. I just submitted it. Okay, yes, I said that it it will be having uh, int max at the last. That's what I guessed. That's how these test cases in LeetCode will be. So last plus 1 is giving me a wrong answer. Why? Because it is going out of integer range. So what I'll do, let me just initialize it as LL. What it can do. So type define long long as LL. So let us see, can I initialize it or not? Here also LL. Wait a second. Yes. Is there anything? No. No, I didn't have anything. So I have initialized LL so that I can't get okay. Did I include this? Yes, integer overflow cannot be represented in int, but I didn't use any int. Last plus 1. No, I think I didn't initialize anything in db. Hi, 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 Thanai. Hi. So I was busy in solving that so that I didn't reply to you. So hi, Thanai 18. Hi, welcome to the stream. Okay, I think I'm doing something wrong here. Thanai, can you please help me? Help me out. So, okay, last plus 1 comma minus 1. What if I just remove it? If I just remove it, now there might be a problem that okay, I can cheat here by for this it can't give you a answer, right? It can't give you an answer. I can cheat it, but there might be a longer test case, a large test case. Last plus one. So yes, sorry. Here last is equal to stones dot back, right? So last plus one. Last is in integer range, and I am adding last is in integer range, which is nothing but this element 2147483647. Int max is in integer range. Here was in integer range, but I changed it to ll. Let us see whether do I get this as a wrong. Can you say hi? Yes, I said hi. Tanai, memory limit exceeded. So how exceeded the memory limit for this? How can I optimize it? So instead of db of k position, uh, can I reach the last element, right? So let us see what are the topics here. Array and dynamic program. That's what I used. So I thought with this long memorization, but it is giving me a what I say memory limit exceeded, memory limit, right? So I need to optimize it. How can I optimize it without using this to uh, int max and int max, right? How can I optimize it? So so what I think is I think we can even solve it with 1D 1D one dimensional db 1D db, right? Let us see. Okay, let us see. Okay, let us see. So let me take the same thing again, 1 to 17, and let me think in this way of 1D db. Okay, how can I solve this in 1D db? Right, first thing, the frog starts at here, right? The frog is starting at here and then going to this one, right? Now after that it can go k plus 1 and k minus 1. But wait a second, the thing is, if the frog lands here, then only it will go it will go to the it can go to the last. But what if I start here last? But how many k minus 1 or k plus 1 I can go with? No, it can't be possible, right? The k and k minus 1, k plus 1 aren't initialized. Now if I take k minus 1, which is nothing but 0, I'll be here only. And then, so what I need to do is something like, can I take this two steps? Okay. Swarup, size Swarup, charge the desk. So it is in power saving mode, size Swarup. So it is in battery saver mode. That's why it is saying it as charge. So okay, it is in power saving mode, energy saving mode. So that's why it is giving this symbol. Okay. Frog jump. I am just solving this size Swarup. I'm just solving this frog jump problem, hard problem in LeetCode, right? But the problem here which I faced is, firstly I submitted this, wait a second, sorry, submissions. I submitted this recursive code, but after that I made it with this one where okay where I initialized this DB, but I got a runtime error and I have solved that runtime error. However, I'm not getting this runtime error again, and I won't be getting even after that. But what is the problem is I'm getting a memory limit exceeded. Why? Because I am just taking int max for n int max of rows and int max of columns, which is nothing but int max into int max. So 2 power 30 into 2 power 30. So it will be a maximum of okay 10 power 6, right? Okay, which is so much large. Hello, unique Vikas. Hello, brother. Welcome to the stream. So so yes, frog jump. I am sorry, I have already said that. The problem is I am facing just memory limit exceeded. So I think we can go with the 1D DB, but the thing which I am thinking is about k minus 1, k and k plus 1, right? So k minus 1, k and k plus 1. Can I go here by k minus 1? Okay. Can I use? No, I cannot use a graph which will give me a large unique okay, a large things, right? But I can do something like okay, 1. I have this 1. Now I have choices 0, 1 and 2, and I don't take this 0, however, and I can take 1, and if I take 1 I'll be drawing, but I can take 2. I can take 2, but okay. But if you see, I think I don't need these many int max into int max. I think I need lesser than this, right? Okay, okay, let us see. But by taking 2 steps, I can go to 3, right? Okay, I can take this 2 steps and go to 3. Wait a second. Okay, so what I am uh, now I got an idea that I think okay. Then you will go there. But if it is not there, I cannot go after 2 or 3 steps, k or k plus 1 steps. So, right. Okay. What is this all? So, I have this. Firstly, can I go to 2 steps? That's what where I am stuck. I can use a 1D DB, but how can I use this 1D DB? Okay, right. Wait a second. I got an idea. Right. Okay, I got an idea. Right. So if you see how easy or I don't know what I need to say, but what I'm thinking is I have this 17 units, right? So what we'll do, let us initialize this 17. I'm just changing the color. So if it is a stone, 0, 1, 3, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then 17. And what I am representing it as 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and then 13, 14, 15 and then 16. Okay. Okay, I think you all got it. Three concurrent viewers for all those three. Thanks for watching this video. Okay, we are at the last part. I think so. I think so. I don't confirm it. So one, so it will be two here. It will be two. So two is not. Okay. Okay, two is not concurrent. Okay. 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 I got an idea, right? So the frog will be definitely here. Sorry, the frog will be definitely here, right? I don't know how the frog looks. Okay, the frog will be definitely here, but there are two choices this frog can go. Is what I'll do here, it will be true. Here, it will be true. Here, it will be. It will be what I need to say. It will be false. It will be false. Wait a second. Can I use false or can I use -1? However, it might be, but k and k plus 1. 1 plus k is nothing but 1, right? 1 k plus 1 is nothing but 2. So 1 plus 1 is 2. So this frog can land here, but as this is a water, but how can I represent this as a water? Is the okay, let it be. So -1, I'm just initializing it as -1 everywhere where I have a water instead of stone, right? So here I initialized 0, but it will be 1 1, and here 0 0 0 0 0 0. Okay, firstly I go with I go from I is equal to 1. Why? Because I am starting at 1. Now I just got this idea. What I'll do is, what is k minus 1? K minus 1 is nothing but uh, nums. So wait a second. Let it be ABC. A is equal to, what is I? Stones of I. Stones of I plus, what is k minus 1? K minus 1 is nothing but the previous steps which I took, right? But okay, that's what where I am confused. So previously I took one step. Okay, I can take one step, or wait a second. What if, wait, what if I stored, what if I stored it like this? I came here, I came here by taking one step. Now I cannot go here, right? So I got one step here. I just storing it as 1. Okay, I'm just storing it as 1. After that, I can't go with 1. A is equal to stones of I plus what I got here. Okay, I'll tell you what I got here. Previous, -1. B is equal to stones of I plus previous. C is equal to stones of I plus previous plus 1. Okay, so okay, for A, wait a second, I'll tell you. So this dog jumps from here to here, right? With how many steps? 2 steps. So here I got with 2 steps. There is only possibility that I can get here, uh, from here to here, or however it might be. There is only one possibility that I can go to this place with only 2. Now as I got here, I change it to 1. Now I have 2. So 2 minus 1 is 1, but I don't go here. 2, so I can go here. So by taking 2 steps, I can reach 5. So as I reach 5, I'll change it to 1. Now by taking 3 steps, I can go here. So by taking 3 steps, I can go here. So as I can go here, I'm changing it to 1. Now if you see, after 3 I am not going to 4, instead I am going to 5, nothing but I am going with every stone. So I go to 5, I got it to here. Okay, that's how I think I solve it, right? I think I need to solve it by using what are the previously, how do you get to this stone, how do you get to this stone? So A is equal to stones of I plus previous minus I. So if let me use the same MP of A. If it is 1, so then only what I'll do is, let me name it as reach. Reach, wait, let it be reach of A. Reach of A is equal to, I'll change it as 1. Okay, that's how I'll change it, right? If it is a stone, then I will make it as 1. But also, what else I need to do? I just took this, previous, right? So what I'm just thinking that previous array, let me name it as previous array. So the previous of a stone can be initialized. Previous of a stone can be initialized. So previous array of A is nothing but uh, previous minus 1. This previous is nothing but how do I get to this element? Uh, okay, right? I is equal to 1. This is nothing but the iteration. So MP of A, if MP of B, previous array of B is equal to previous, okay, reach of B is equal to 1, okay, if MP of C, previous array of C is equal to previous plus 1, and reach of C is equal to 1. I think I'm going in the right direction. For I is equal to 1, I is less than n, I plus plus, I'll be using a for loop. I think you might get this. I'm just going with this. How many steps I can take? But if you see, I got I I can take I have I think I got, okay, here I can take 1 step, here I can take 3 steps. So for I think I'm just for now I'm thinking that to get a stone there is only 1k. Okay, I'm for now I'm assuming, but there might be a possibility that there might be many previous that can give me unique because ff. Okay, hi. So it will be something like, I am just thinking like that I can only get one previous for every stone. Okay, I'm just thinking like that. Okay, so what are the things I need to initialize? Previous array of size, what will be the size? Last, that's it, I think that's it, comma minus 1, and reach of last, comma minus 1. And for every stone, for every non sorry, for order it is minus 1, for stone it will be 0. Okay, I need to go with this stones again. So for int I is equal to 0, I is less than n, I plus plus. So reach of stones of I is equal to 0. Okay, so I think this might work out. So I just used a 1 DTP, but I'm still not sure that to get to uh one stone, there might be I don't know how many possibilities there might be. Okay, let it be. So I need to just code this, right? Start from the beginning. So first thing, let us initialize what else I have initialized first. Last need to be initialized. Int n need to be initialized. So int n is equal to stones dot size, and then last is equal to stones of n minus 1. So it should be, I think, at the okay. Okay, so I got the last two. Now after that I need to initialize previous array and reach. So vector of int previous array of n comma minus 1, and then reach of n comma minus 1, and then after that for int I is equal to 0. Okay, for int I is equal to 0, I is less than n, I plus plus reach of I. Okay, reach of nums, sorry, stones of I. Sorry, I made a mistake here. Yes, I didn't make. Oh, okay, it should be 0. I thought it would be nums. I thought I wrote it as nums, but sorry, I wrote it as stones. Nothing to worry. Okay, for I is equal to 1, I is less than n. So for int I is equal to 1, but I need to return false if stones of 1 is not equal to 1, return false there itself, and reach of 1 is equal to 1. Okay, I can reach this stone, right? Less than n, I plus plus. Now I need to get this unordered map, right? Mp of stones of I plus plus. So initialize unordered map of int mp. Okay, I got this I is equal to 1. I need to start with I is equal to 1. Int a is equal to stones of I plus previous minus 1. But previous of 1, previous of 1 is equal to 1. That's it, right? And int a is equal to stones of I plus, wait a second, previous minus 1, and b is equal to stones of I plus previous, and then c is equal to, wait, stones, okay, stones of I plus previous minus 1. Okay, okay, I got ABC, right? So three different things. Now if mp of a, I need to write it all. If mp of a, previous array of a is equal to previous minus 1, previous array of a is equal to previous minus 1, and then reach of a should be 1, reach of a should be 1. If mp of b, then previous array of, wait, b is equal to previous, right? Reach of b is equal to 1. And if mp of c, previous array of c is equal to previous minus, sorry, plus 1. Okay, then reach of c is equal to 1. Okay, I need to return if reach of last, wait a second, I'm just running it. I don't know whether it gives me a wrong answer or right answer. Okay, it need to be initialized after that. Previous, okay, previous array, it should be previous array. Okay, previous minus 1, no to be resolved, you mean call it reference to overload function could not be solved. Okay, Previous minus 1. It is confused with previous minus 1. What is this previous? So let me initialize previous is equal to previous array of stones of I. I think I'm not wrong. Okay, that's it. Previous array of stones of I. That's it. Runtime error. Reach of stones of I is equal to 0. No, it shouldn't be end, right? It should be last. Previous array is also to the last. Last is nothing but the last element in the stones. So it is also giving me reach of stones of I. So let me just print cout stones of I. Wait, where did I got this? Wait a second. Okay. Stones of I. So read should be initialized with +1. Why? Because for 17 it is initializing only 16 sized okay, it is initializing till 17 size, but it is going till the index of 16. That's it. So that's why I got a wrong answer. Okay, runtime error again. Last +1. Okay, again LL again. Okay, last LL. I'm just type define long LL. So let us see whether does it runs or not. No, again the same problem. Previous +1. Okay, previous +1 and previous -1. I think that somewhere I got a 0. Okay, wait a second. If you see, the memory limit is exceeding. Wait, how can we solve it? Even I think we are not given with, wait, no, we are not given with the topics are given, but the hint isn't given. When you try to jump between stones, but the gap is too larger. Oh, advice for all the beginners for debugging: sticks to concepts and okay. We go offense to start, set up a DDR of current stone jump. We'll store whether it's possible to reach the end from a specific stone with a certain jump count. But the last, if I initialized it with int max +1, it is giving me wrong answer. Using map to array and index with the stone's position and significantly speed up your algorithm. This time for need for searching and improves overall efficiency, as you can quickly access the stone's position and instead of editing through the array. Yes, I use this maps. I should personally remember sometimes it's a smaller optimization that can make a big difference. Dive deeper into the problem, consider edge cases, and explore different scenarios to fine tune your solution. But I think uh, let me do one thing. I'm just submitting it so that even though it can be, wait, for this I got a false. So even after initializing this last and all, I got a wrong answer. Okay. Type define long LL. So and so that's what I let me do this thing. If nums sorry, stones dot back is equal to, copy this, I'm just copying it. So sorry for doing this, but doesn't have any option. So if so, what I'll do, I'll just return false, but let me do whether it runs for other test cases when I submit it. Okay, it ran. Okay, I'm getting the same memory limit exceeded problem. For the description, this person saying that Hemant Kumar is saying that the problem appears simple using memory can be key to solving it optimally. With these approaches, you can efficiently store and retrieve solutions to subproblems, avoiding redundant calculations and making the algorithm being fast. So if you see, I'm initializing the int max into int max. So that's what I'm getting the wrong answer. So here, triple nine, triple nine. So it is the bigger test case. Wow, binary search. Again, skipping stones and binary search. You might have noticed that you can skip certain stones if your jump is large enough. To handle this efficiently, consider using binary search to find the stone index that matches the frog's next position after a jump. No. Feel free to share your thoughts and experiences as you work on this problem. If you encounter any roadblocks or have, okay, I'm having so much confusion about this. I got this uh, small test cases passed, but the main problem I got is I'm initializing this with a larger number. That's where the problem arises. That's where the problem is arising, right? Assigning again a deeper problem. Okay, how can the frog jump? Okay, okay, return true. The frog. And I still cannot pass the same solution passed easily using Java. I don't know why. It is just me, or is the problem screen itself confusing? In my opinion, it should be true. Initially, I have k equal to 1. I can jump k plus 1 units to get to 2. So output should be true. This is medium, not hard. Okay. Okay. N square is cost. N square is trivial for this question since it is a hard. I wasted time looking for an end solution. Okay. So they said that end solution isn't possible. Okay, hard doesn't mean n square constraints. I believe there is an n log n. So they are saying that big of n doesn't work. But the main problem that I faced is I am initializing this last plus one. That's what I'm having the problem. Why did the frog? Okay. Include this in your if stone x is not reachable the k value, it does not mean that the stone x is not reachable at all. It can be reached with any other k values. Okay, okay, I'm just using this solution so that I can go with the one video solution. Oh man, they use this graph. Okay. Attentive memorization. Okay, current stone index, length of the last gem taken, stone positions, and map from stone positions to its index for big of one lookup. Okay, memorization stores. You can reach the end from stone I with last jump k. Okay, let it be what it might be. I is equal to v dot size return true. That's what I written here. Okay, I written one, but however I written one. Okay, db of, yes, did the same thing here, but they used bool into value is equal to v of I, current stone position. Okay, so the main difference between our code and his is we used they used this vector of int and they used int index, so that they can go with I, right? Value is equal to v of I, current into next index is equal to mp of k minus 1 k1. Okay, okay, but I did the same thing, but the thing with, okay, they used only n, but I here used last, right? That's what we are going wrong, right? They used only n and they have just initialized whether we can go to the index or not, to that index stone or not. But what we have done is we have gone to the value. Okay, so we have gone to the value itself, so that we are getting a wrong answer, right? So no need of using this ll int last is equal to stones plus 1 without size. We can just use n, right? We can just use n. N is just nothing but stones dot size. Int n is equal to stones dot size. Okay, I have initialized this, no need to do this. db int k. Now with stones int k, instead of int k, let me use this I. So let me change this as bool. So return false here, return true here. db of k position, I think nums of stones of I think, no, I and k. Okay, I and k. What is this k again? db of I and k with last jump k. So what is the last jump and also what is the index mp? So sorry, if we can reach, okay, then there is no need of this position. So let us remove this position from here and camera on, but we need to we need to we need to just do this changes. So return true, return db of k, sorry, I and then k, I and k, I and k. So if these three, anything of this is true, then I'll return true. Now if, okay, values, oh yes, here is the first thing. Int value is equal to stones of I, no, v, instead of v is nothing but vector which we got, so nothing but stones of I, no matter. So int k1, no need to initialize all this. So bool a is equal to false, b is equal to false, c is equal to false, false, right? Now if k minus 1 is greater than 0, then in next position no need to write value plus k plus 1. Value is nothing but, yes, there itself. So if mp dot find next position is nothing but value plus k plus 1. Value plus, what is k plus, sorry, value plus k1, nothing but k minus 1 is not equal to mp dot end. Okay, then next index is equal to mp of next position. So what we are storing in mp is not uh, plus 1. It is, we are just storing I, where the stone is present in which index. So mp of v of I, yes, mp of number is equal to I. Okay, yes, I am correct, right? If mp dot find value plus k minus 1 internet next index, so a is equal to first function is nothing but what, yes, function func v. What is this v? So let me start with I and k. So here they use this I and k instead. We are next index comma k1, next index comma k1. At first let me stones I comma k, next index comma k1. K1 is nothing but k minus 1. Next index is mp of next position, right? mp of what is the next position value plus k minus 1. And what is this k1? K1 is nothing but k minus 1, right? K minus 1. Okay, yes. So this is the same thing again for k. I just need to change here k every time. And here k plus 1. Here k plus 1. K plus. I think it might work now. Where is this position mp of position? Okay, shouldn't be mp of position, right? It should be something like mp I is equal to v dot size minus 1 return true. Size minus 1 return true. So I is greater than v dot size minus 1 return false. Okay, this should be here return true v dot size stones dot size, yes, ik, yes, got I and then k, yes, k plus 1 k minus 1 k p and stones. I think we doesn't missed anything dp of position. Here it should be I and k. Okay, so it should be int, sorry, stones. Sorry, I need to charge my laptop. Sorry for the inconvenience. Right. So stones dot size stones of I is equal to I. So I need to start with k1 or something like that, right? So we need to start with 0 0 and same thing, right? We need to return just function 0 comma 0 0 comma 0 comma imp stones. Okay, false true. Okay, I got wrong answers, blunders, right? Let us just copy this, right? It's called stones of I. I and then k. Okay, I is greater than, okay, then we'll be returning false. Returning value is equals to of I, k minus 1, k plus 1 is greater than 0, in position is equal to value plus k1. So find, let us just take in next position is equal to value plus k1, nothing but k, nothing but k. Okay, I'll use it here too. Now here it will be next position, here it will be next position, next position. Okay, now it's a function of we are using mp of something, right? mp of next position, next index is mp of next position. Now I'm reading it as I, right? Yes, mp of next position will be mp of next position, mp of next position, of next position. Okay, let us see the whether it will it run or not. Function of np, no, it can't be the wrong answer, right? Mm, did the same thing again. But I'm just where I'm missing it. So bad. B and here it is C, right? What mistake, what a blunder, right? So that's where I got mistake. I'm just wasting my time over 10 or 15 minutes like it. So this is today's stream. I think it's long. Wait a second. How much time I took to solve this? Uh, okay, 1 hour 38 minutes, right? So I'm just stopping it here. I started at I think 8:15. Now 8:15 plus 40 minutes, 8:55 and 9:55. Okay, so I'll be stopping here. So if you have any doubts, please do comment in the comment section. Yes, and then please do follow in my LinkedIn. I have given the LinkedIn profile in the description, and do like this video, share to friends, and do subscribe to my channel. Thank you.